All right. So like Gregor mentioned, I apologize to the Ocean Tech class. This is going to be a very familiar presentation. I believe I know everyone here, but in case I don't, my name is Kirsten Watson, and I'm a research assistant at CMAR. And as Gregor mentioned, I'm going to be talking about our coastal monitoring program, the oceanographic data that we collect, and the vandalism that we've experienced. There we go. So for a bit of background on CMAR, if you're not familiar, we support the sustainable development of coastal resources in Nova Scotia. And we do this by leading and supporting science research projects in collaboration with government, industry, and other marine users. And we were originally developed to support the aquaculture industry, but we've since broadened our scope to include other users of the Nova Scotia coastal environment. And some of these include scientists and academia, industry, through site selection, engineering decisions. Then we have government to help support science-based decision-making, and other stakeholders, including conservation, NGOs. And one of our ongoing programs is the Coastal Monitoring Program, and this is where we collect high-resolution oceanographic data along the coast of Nova Scotia. So our coastal monitoring program is divided into 3 branches. We have water quality, current and waves, speed and direction, and then our wind and wave buoys. So under the water quality branch of the program, we deploy what we call sensor strings, and these are made up of a subsurface buoy. We have autonomous sensors at varying depth intervals, and these are attached to an acoustic release. And the sensor strings measure temperature, dissolved oxygen, and salinity at locations across the province. And they're typically deployed for several months at a time, with some of our time series stretching over 5 years, which is pretty awesome. To date, we've collected data at 86 locations, and this is shown on the map with the blue dots. And at any given time, we have over 65 strings deployed in the water. So this is just an example of high resolution temperature data. So you can see the different depths by the different colors. You can see at this location, the water becomes really stratified in the summer. And then in the winter, fall months, you can see it becomes really well mixed. And in this example, that red dashed line is the super chill threshold, which is a critical threshold for salmonid aquaculture. And temperatures under this can be lethal in a very short period of time. So you can see at this site, it wouldn't have been a good picture for salmon aquaculture. Next, we have the current and waves branch, where we deploy ADCPs, or acoustic Doppler current profilers. And we do this in collaboration with the Nova Scotia Department of Fisheries and Aquaculture. To date, we've deployed 74 ADCPs across the province, and those are shown by the orange dots. I think a couple might be missing, but and then the plot on the left just shows a site in the Bay of Fundy. And I like this plot because you can really see the strong influence of the tide on the currents, where we have the tide coming in and then the tide going back out. And lastly, we have, or had, buoys deployed in 6 bays in Nova Scotia. And these measure wave height, wind speed, and direction. And the data is streamed in near real time onto the CU's Atlantic website. And then these buoys help support the development of an exposure model of the coast of Nova Scotia. And this was done in collaboration with DSA. My dog's barking. So the data from our wind and wave buoys help model the maximum wind speeds and wave heights along the coast. And this can help guide engineering design of aquaculture infrastructure and among other uses. And these reports are available on our website. And at CMAR, we follow FAIR data principles. So that means all of our data is findable, accessible, interoperable, and reusable. And it also means our data is publicly available through summary reports on our website. And then all the process data is available on the Nova Scotia Open Data Portal, as well as the CUS Atlantic website that we learned about last meeting. And to date, we've shared, To date, we shared over 30 million data points on these 3 platforms, and our data has been viewed over 12,000 times. So now we'll get into the fun part, which is the vandalism. It's a challenge that we continually face, and both intentional and unintentional vandalism. So I've included our sensor strings in this just because it is deployed oceanographic equipment, and we have faced a lot of issues, and then I'll get more so into the buoys. So with our sensor strings, they have a subsurface buoy, so it's not really visible from the surface. So there's less chance of someone intentionally vandalizing it. However, they do show up on a fish finder, and this has led to people finding and returning our equipment to us. And they're also more susceptible to unintentional vandalism, which has occurred from fishermen hooking our gear or hooking our sensors in their gear. And then we've also just had curious people that pull up our strings, check them out, and then redeploy them for us, sometimes hundreds of meters away. And lastly, we've also just had strings that disappear altogether from maybe a storm or who knows what. And then the case of our surface buoys, since they are visible at the surface, they seem to be an easy target for intentional vandalism. And I'll go through some of these examples. In St. Mary's Bay, we were notified that our buoy went offline. So we sent our contractor out to retrieve it, and it appears the buoy was used for target practice. I wish I had some exciting pictures of the bullet-riddled buoy, but here we are. So yeah, it was covered in bullet holes, the solar panels were damaged, and it was repaired and redeployed at the same location. And then a week after it was redeployed, it was involved in a collision with a scallop dragger, and unfortunately at that point it was damaged beyond repair. And this collision happened despite the buoy being equipped with lights and radar reflectors and reflective tape. So it was unfortunate. And then in October of this past year, we redeployed a buoy in St. Mary's Bay. And on Christmas Eve, we received notification that the battery's malfunctioning, and now it's having transmitting issues. So currently that buoy needs to be retrieved. This one wasn't really vandalism, but it's still expensive. In St. Margaret's Bay, we had a buoy that was cut from its mooring, and we heard through the community grapevine that a fisherman thought it was a whale acoustic detection device. Apparently, they didn't want the fishery to be shut down, so they decided to get rid of the buoy. In Chedabucto Bay, our buoy was severed from its mooring from an unknown cause, and luckily we had a contact in the area that was able to retrieve it. That buoy has not yet been repaired. However, the estimated cost for repair and redeployment is around $18,000. And lastly, this past fall in Jordan Bay, our buoy that's deployed on an aquaculture lease was found wandering, and it was retrieved. It looks like it may have been an engineering defect in this case, where the shackle broke away from the anchor. That buoy was repaired with cost around $12,000, and that's the one that's currently in St. Mary's Bay that isn't functioning. So we know how valuable this oceanographic data is, but what's the cost? In the case of our sensor strings, since 2018, we've lost 16 sensor strings, or they've been stolen. And each sensor string is valued at roughly $15,000 to $20,000. And then we have our deployment costs and retrieval costs, which are $5,000 to $10,000 each, depending on the location. So that puts us at about $400,000 to $600,000 in lost gear and contractor costs. And unfortunately, when we lose these sensors, we also lose the data that they logged. So this creates breaks in our time series. And in the case of time series that span multiple years, it's really disheartening when we lose those sensors. And as for the buoys, we have a buoy graveyard valued at roughly $190,000. And this is in the form of a U-Haul unit full of buoy parts and skeletons. And after all of this, we only have a single buoy in the water that is currently not transmitting any data, and it needs to be retrieved and fixed. So this leads to my question: where do we go from here? Do we keep fixing and redeploying buoys when they don't seem to stay in the water longer than a couple months? And can we keep doing the same thing and expect a different outcome? So with that, I'll open up the floor to comments, questions, solutions, whatever you have.